submit week 5 assignment, and then you will go on. Okay.
Yes, ma'am.
So yeah, this is not a part of qualifier exam, but it's a part of our course. So now let's start with 1-1 functions. Yeah, I think most of you haven't seen any lectures and all those things, so it's okay. You just grab the concept here. So these are the basic concepts. It's not that difficult. Also, it's an important topic, so it's better if you understand now.
Ma'am,
Okay.
if we
Yes,
hello,
sir.
yeah,
Huh.
if we skip any subject, for example, after qualifying, if we skip that subject, in the next term we have to start from the beginning.
Yeah, you have to start from the beginning.
Oh, okay.
Okay. Okay, so what is 1-1 function? So you know what is a function means, that map from a set to another set, which says that every element of A, for every element of A, there exists a unique B such that F will maps that A to B. Now, what is 1-1 function? So 1-1 is just a specific, a special type of functions we have to consider. So suppose you have a function. So definition goes like this. So I'll tell you that there are several ways by which you can check that a function is 1-1 or not. So those ways we will discuss in meantime. But start with the first definition. Okay. So what does the definition of 1-1 function means? So it says that a function f is said to be 1-1 if x1 not equals to x2 implies f of x1 is not equals to f of x2. Okay. So this is the definition of 1-1 function. What does it implies? It implies that if you have two different input points, then these two different input points should correspond to two different outputs. It should not happen that these both input points will give you the same output. And this thing should happen for all x1 and x2 belongs to the domain of F. Okay, so that means no matter what distinct inputs you will take, for those distinct input, the output should be different. Okay, so if this thing happens for all values of the domain, then that function is known to be a 1-1 function. So that means if you take two different input, x1 not equals to x2, then the corresponding output should be different. That means f of x1 should not be equals to f of x2. So if a function satisfies this property, then that function is known to be a 1-1 function. Okay, is the definition clear? Simple definition. For two different inputs, there should exist two different outputs.
Yes, ma'am.
Okay. So
Yes,
now
ma'am.
we will consider two examples, one function which is a 1-1 function and another one which is not a 1-1 function. Okay. So I'll take very basic examples. So suppose you have a function f of x is equals to 2x plus 3. Right. So this is a function, just the equation of line. Now here, assume that you will take two different values, x1 and x2. Okay. So suppose I have taken any two distinct values, x1 not equals to x2. Right. So you guys know if x1 is not equals to x2, then twice of x1 is not equals to twice of x2. Correct? Because if obviously if x1 not equals to x2, then multiplication of 2 does not change anything in the inequality, right? So that means that 2 of x1 is not equals to 2 of x2. And similarly, you can say that, okay, then 2 of x1 plus 3 also not equals to 2 of x2 plus 3. Okay. So these steps are kind of obvious. If you take two different values, then twice of x1 is not equals to twice of x2, and plus 3 is also won't change the dot equal to thing. Again, 2 of x1 plus x3 is not equals to 2 of x2 plus x3. And why I'm doing this step? Because here, if your function is 2x plus 3, then you guys know that f of x1, so that means if you substitute x1 in place of x, you will get 2x1 plus 3. So that means on x1, the output is 2x1 plus 3. And on x2, the output is 2x2 plus 3. So that means here is we have 2x1 plus 3, which is f of x1, and this thing is not equals to the output on x2, that is f of x2, which is 2x2 plus 3. So that means here we have assumed x1 not equals to x2, and we have proved f of x1 is not equals to x2, right? So this is we suppose, and this is our proof. So that means this particular function satisfies the definition of being 1-1 function, right? So here what it
Ma'am, but
implies, it
we
implies
can
that
also prove, na, ma'am.
we can also prove.
X1 is equal to x2.
No, but yeah, I'll come to that. Why we are not doing that? So I'll come to that.
Because 2x 2x 2x1 plus 3 is equal to, let's My
Yeah,
answer is
so in place of inequality, you just want to take equal to, right?
yes, ma'am. Yes, ma'am.
That's also you can do, but there is a little change when you consider equality in this case. Okay, so I'll come to that too. Yes, Ronak, any doubt? Ronak Roy?
No, ma'am, I have a doubt from week 1.
Yeah, we can take that doubt in the revision session. So you can ask whatever whatever doubts you have from week 1 to week 4
Ma'am,
in the revision session. Yes, Raghavi.
good.
Sorry, your voice is not clear.
4.3 activity question number 3, ma'am.
Yeah, so see, whatever doubts you have from week 1 to 4,
4.3 activity question number 3.
yeah, you can ask those doubts in the revision session, because if I started taking doubts from week 1 to week 4, we can't able to complete the theory now, right? So purpose of today's session is week 5 theory. So please stick to that. If you have doubts, you can ask in the revision session, or else you can also ask in the TA sessions. Also, I think if you have doubt from activity, then TA may have covered those doubt in the previous sessions. So you can go and check the recordings if you.
Ma'am, I asked to the instructor and TA before you,
Mhm.
but anyone can't solve this problem. Matlab, he was not answering.
Okay, so at the end of the session, you can ask. Otherwise, I'll break my flow. At the
Ma'am,
end,
show
I'll
the
ask.
definition, please.
Okay,
Yeah,
ma'am.
at the end, you can ask. Okay. So that means by the definition, we have proof. First of all, we assume that x1 not equals to x2, and then we have claimed f of x1 is not equals to f of x2. So that means we have proved that this function satisfying the property of being 1, 1. So here we get that if x1 not equals to x2, then we can say f of x1 will not equal to f of x2. So that means f is a 1, 1 function. Okay, so this is the first example where function is a 1, 1 function. Now I'll take another example where the function is not a 1, 1. Okay, so Ronak, do you have any doubt? Yeah, fine. So now let's take another example. I'll again take simple example, just being a parabola x square. Okay, so here f of x is equals to x square. Now here you can see that if you take two values, x1 to be 1 and x2 to be minus 1, then obviously x1 and x2 are different, right? x1 is not equals to x2. But corresponding to these two different input, if you compute the output of this function, that is if you compute f of x1, that will be 1 square, which is equal to 1. And if you compute f of x2, that is also equal to minus 1 the whole square, which is equal to 1, right? So here what is happening? We have x1 not equals to x2, but f of x1 and f of x2 both are same. x1 is equals to f of x2, which is equal to 1. Right? So that means here this function is not satisfying the property of 1, 1. So you can say that f is not a 1, 1 function.
Ma'am, sorry for the interruption, but when will
Yeah.
be the revision session for week 1 to 4, ma'am?
Yeah, so the revision session is before quiz 1. So let me see. I have just scheduled. So in the calendar, you can also check. It is on 8th of July, I guess. If I'm.
Okay, ma'am.
Yeah.
And also, this notes will be in the calendar, ma'am. The
Yeah,
link.
these notes will be in the calendar. I'll upload these notes over the calendar.
All right, ma'am. Thank you, ma'am.
Okay. Yeah, so that means this function is not satisfying the definition of being 1, 1. So it's not a 1, 1 function. Okay. So is these both examples are clear to you?
Yes, ma'am.
Okay. Now,
Yes, ma'am.
as Ronak, someone mentioned, right, that what happen if you consider this thing. Okay, so suppose if x1 equal to x2 implies f of x1 equal to f of x2, right? So is this the definition of 1, 1? So the answer is no. Why it's no? Because see, this definition, this thing follows for every function, because the function has the property of unique, right? As someone already I mean, in this example you guys mentioned that what happened in place of inequality, right? I started with x1 not equals to x2. What if you start with x1 is equals to x2? So if you start with x1 is equals to x2 and you try to claim that f of x1 is equals to f of x2, and if you consider this as a definition of 1, 1 function, then it's not correct definition of 1, 1 function. So the answer is no. Why it's not a definition of 1, 1 function? Because see, this thing is true for any function, because this is true for any function. true for any function. Because function has the property of uniqueness, right? We know that. What is the definition of function? So the definition of function is for every a in A, there is a unique b in B. There is a unique b in B such that f will map A to B. And here, if you consider this thing that you have taken one input, then obviously for that one input, you will always get one single output. Okay, so if that thing
Excuse
is
me,
a
ma'am.
function, yes, sir.
Yeah, if we start from f of x1 is equal to f of x2 and then finally solve that
Correct,
x1
correct.
is equal to x2.
Yeah, that's the definition of one function. I'll come to that too. So the next point is that only that you can actually change the statement into equality, but for that you have to change the condition of your hypothesis and result. So that means you have to consider x1 equals to f of x1 is equals to f of x2, and then you have to claim x1 is equals to x2. Okay, so this thing is okay. So that means you cannot consider this as the definition of one function. This is in general true for any function, because function says a single input will always map a unique output. Okay. In function, this thing is true. That if you have two different input, then it can go to a single output. Right? This is true in functions. But if you considering any map which is a function, then a single input cannot be mapped to different output. This is not true in function. True if f is a function. Right? This thing we have already discussed in detail. That because it violates the word unique. Right? So unique is not there. That's why this thing is not possible. That's why you cannot consider this as the definition of one function. Okay. Now
So I
there
have a
is
doubt
one more
here,
thing.
small doubt. So
Yes.
if so you wrote it in converse, right? Like first initially you wrote it like x1 not equal to x2, and then the converse you're saying is true, correct?
Not the converse. See, the
Opposition.
converse of this statement is if you know the statements that when you want to change the equalities negation, then the equality reverse actually. So that means here x1 not equals to x2. So this is not the converse of that statement.
Okay, can I write it in tautology? If x1 is equal to x2, if and only if f of x1 is equal to f of x2.
Yeah, you can write that. If you, in place of equality, if you consider both-sided equalities, that is if and only if condition, then that you can consider as the function, as the definition of function, because it involves the second thing. Okay, so I'll come to that. So here original
Ma'am,
statement.
can you actually explain in terms of equality? Because that's how we learned in 12th, so it's
Yeah,
getting
yeah, yeah.
confused.
Yeah, I'll come to that too. So,
Ma'am,
yeah,
if
what
in
else?
any question x1 is equals to x2 and
Yeah,
uh,
x1 is equals to x2.
ma'am, can you hear me?
Yes, you're audible.
Ma'am, if any question x1 is equals to x2 and f of x1 is equals to f of x2, then we consider it as 1 or not?
No. We cannot consider as, because I just told you that it's true for any function. Okay, it's not a particular thing. It's true for any function. If you are considering a thing as a function, then that function follows the uniqueness property, right? So if you take a single input, it will obviously map to single output. So this thing is in general true for any functions. Okay, so what does equality say? So here, see, we have a statement that x1 not equals to x2 implies f of x1 not equals to f of x2. So if you want to change this negation into equality, so what you will do? So this statement is similar to saying that if you consider the same input, that is f of x1 is equals to f of x2, then you should be able to prove x1 is equals to x2. So this thing you can consider as the definition of one function. This is true, because here what is happening, we are changing the equalities and also we are changing the negation. So it both statement will refer to the same thing, because what we are, in the first statement what we are saying that if you take two different inputs, the output will be different. And the second statement also you are saying the same thing, that if you take same output, then that output is related to only one single input. Okay, And that's what the thing we want to prove if we are considering 1, 1, right? So in the first statement, what does it say? It says that if you take two different input, x1 not equals to x2, then they correspond to two different output, f of x1 not equals to f of x2. This is, you are saying in the statement number A, statement A, right? But what does statement B say? Statement B says if you consider the same same outputs, then the corresponding input will be same, right? This is you are saying in the statement B, and which is the definition of 1, 1, that for a single for any output there exists a single input. Okay, so that's the meaning of 1, 1, right? That the one thing is corresponding to one thing only. Okay, I hope that's clear. Is that clear? The statement. So that means you can use both as the definition of 1, 1 function. Whatever you feels easy. If you want to handle the equality parts, that's also you can handle. If you want to handle inequality, that's also true. Now let's try to prove that thing with prove that this function f of x is equals to 2x plus 3 is 1, 1 using the equality. Okay, so for that, what you will do? So we'll assume that suppose f of x1 is equals to f of x2, right? So that means 2x plus 3 is equals to 2x plus 2x1 plus 3 is equals to 2x2 plus 3 plus 3. Now what you can do, you can cancel out 3 from both sides. That means 2x1 is equals to 2x2, and you can easily figure out that x1 is equals to x2, right? So this is your assumption, and from this we prove that x1 is equals to x2. Okay, so that's also you can prove that a function is 1, 1 function. You can use both statement, the A statement or the B statement. Both will work. Is that clear? Fine.
Yes, ma'am.
Okay. Now,
To prove a
these are
function
the
is a
two
one
ways.
to one, at least, ma'am, to prove a function is a 1 to 1, we can use both the
Mhm.
methods, ma'am. The
Yeah, you
function
can
should be
use.
dislike or the function should be like.
Yeah, you can use both the methods.
Yes, ma'am. And if the assumption is f of x1 is not equal to f of x2 means we should get the same as x1 is not equal to x2.
No, that's not the thing. See, if you have f of x1 not equals to f of x2, then obviously x1 not equals to x2, because that's the meaning of function. So don't get confused. See, you're saying that can we consider this as a definition that x1 f of x1 not equals to f of x2 implies x1 not equals to x2. This is in general true for any function, because the function says that if you have two different outputs, obviously they cannot map to a single input, right? This is not true in function. So this is not a definition. Okay, because it's in general true in any function. So it's not a definition of 1, 1 function. Is that clear, Nidish?
Yes, ma'am. If the question is asked, ma'am, if the function is true, it is a 1 to 1 function. Is if we ask means what should be our answer, ma'am?
So if it's a 1 to 1 function, means it should satisfy one of these statements. Either x1 not equals to x2 implies f of x1 not equals to f of x2, or f of x1 is equals to f of x2 will imply x1 equals to x2. So with the main concept is for a single output you should get a single input. So this 1, 1 means for one input you have only one output. So this thing we can justify by these two statements.
Yes,
Is
ma'am.
that clear?
Yes, ma'am.
But this one you cannot consider because it's in general true for any function. If you consider a function, then it's in general true. Every function will hold that property. So 1, 1 is not a special thing then. Okay.
Yes,
So
ma'am.
now we have one more the method by which we can consider that we can say that a function is a 1, 1 function or not. That is the graphical method, or it's also known as horizontal line test. Okay. So what is horizontal line test says? It says that if you have a graph of a function, and then by observing the graph, if you want to figure out that function is 1, 1 or not, then what you will do, you will draw several horizontal lines. Okay. So suppose this is the graph of function you have. And if you want to figure out that this graph is not a 1, 1 function, or it is a 1, 1 function, then what you will do, you will draw several horizontal lines. We know that what is horizontal line means lines which are parallel to x-axis, right? Horizontal lines means lines parallel to x-axis. So you'll draw several horizontal lines. Okay. And if you get, by chance, if you got one single horizontal line which intersect the graph more than once, okay, for example, here we get so many lines which intersecting the graph more than once, but consider this particular line. Okay, so consider this line. So this line intersecting the graph more than once. So what is happening if a horizontal line intersect the graph more than once? So now can you guys tell me what are the coefficients? So suppose this is the value y is equals to 5, and suppose this is x is equals to 3, and this is x is equals to let's say 6. So can you give me the coordinates of point A and B? What are the coordinates of point A?
Ma'am, 3, 5.
3,5.
3, 5, and the
3, 5,
coordinates of point B will be
6,
6,
5.
comma 5,
6,
right?
5.
Now, if this is the graph of function f of x, then what is happening here? We are getting f of 3 is equals to 5, and also we are getting f of 6 is equals to 5. Correct? Because that's how we plot the graph. Plotting the graph means plotting the graph of a function means plotting the points x comma f of x. So here, if a point A is lying over this graph, so that means at x is equals to 3, the output of function is nothing but 5. So that means we are getting f of 3 is equals to 5, and also we are getting f of 6 is equals to 5. So here what is happening? We have two different inputs, 3 not equal to 5, 3 not equal to 6. But over these two different inputs, we are getting same output, f of 3, which is equal to f of 6, which is equals to 5. Right? So that means if a horizontal line intersect the graph of function more than once, then that function is not a 1-1 function. Okay, so that's the meaning of horizontal line test. I'll state it. What does it mean? So if if a horizontal line cuts the graph or intersect the graph more than once, if in place of a, I can write any. So if any horizontal line, no matter what horizontal line you will draw, you can draw infinitely many horizontal lines, right? So, but for saying that that graph is not a 1-1 function, you just have to pick one horizontal line which intersect the graph more than once. Then that function is not a 1-1 function. Right? And the reason behind that is simple, because if it intersect more than 1 points, then you will get such two different values of x for which the corresponding value of function is same. So that means for two different inputs, you will get the same output. Okay, is that clear?
Parallel to x-axis, right?
Sorry, what?
It should be parallel to x-axis.
Yeah,
Right?
yeah, parallel to x-axis.
Okay.
Okay, so horizontal means parallel to x-axis only. Okay, so now I'll ask you guys one question, so you can figure out that what is the answer. So suppose I have a function like this. So suppose f of x is equals to x to the power 4 plus 3x square plus 1. Okay, so suppose this is a function. Then can you tell me, then is this a 1-1 function? Yes or no? Just mention in the chat. Okay. Just recall your knowledge of polynomials and then you can answer. Is this 1-1 or not? Message in the chat. Okay. Not one answer. Correct. So it's not a 1-1 function. Why it's not a 1-1 function? Because see, here we are considering a polynomial which has degree 4, right? So here you can consider, you can what I want to say is you can figure out the end behavior of this function, right? So that means as x goes to infinity, this f of x will go to infinity only, and as x goes to minus infinity, this f of x will also go to infinity, because it's an even polynomial with positive coefficient, right? So this end behavior is fine. So that means if you draw the graph of this polynomial, no matter what it looks like over here, whatever the roots or whatever those things are, but ultimately at the end, this polynomial will grow like this from this direction and like this from this direction. Okay, so that means you can easily figure out one horizontal line which intersect the graph of polynomial at more than 1 points. Okay, so that's why it's not a 1-1 function. So from this, can you figure out one thing?
Only linear functions are 1-1.
Yeah, linear functions are always 1, but you cannot use the word only, right? Not there are several functions which are 1, except linear functions too. So, for example, f of x is equals to x cube is a 1 function, right? So this function is not a 1 function, but in general also you can state a general statement that every even polynomial, so even polynomial means polynomial of whose degree is even, polynomial whose degree is even, right? So that means every even polynomial is not a 1 function, because it will have the same behavior as x goes to infinity or x goes to minus infinity. Either it will goes towards infinity or it will goes towards minus infinity. In both the cases, you will always find a line which intersect the graph more than once. Okay, so that's the thing. So here you can say that every even polynomial is not a 1 function. But same thing we cannot say about the odd polynomials. Why? Because you have two odd polynomials. One is 1 and another one which is not 1. So we can't say this about odd polynomials, right? Because we can consider simple examples. So suppose f of x is equals to x cube, and we have another example. Suppose f of x is equals to, I'll write down it in a factored form so that it will be easier to imagine the graph. Okay, so that's x square into x minus 1. Okay, so f of x is equals to x cube will have very simple graph. So it's like this. Right? So here you won't get any horizontal line which intersect the graph more than once, right? Every horizontal line will intersect the graph exactly once. So that's why this is a 1 function. Also, you can figure out by the expression, right? If you take f of x1 is equals to f of x2, that means x1 cube is equals to x2 cube, and that means x1 is equals to x2. So it's simple that it's a 1 function.
Sorry to interrupt, ma'am. How
Yeah.
to count the turning point to see the function? Means without the explanation. Means how can we count that?
See,
How many turning points?
yeah, if you want to count turning point, the only thing is there is you have to draw the graph, right? Once you draw the graph, then after that you can figure out that what are the turning points. There are actually not explicit methods to just by looking at the graph finding the turning point. We can say that by finding the degree, that if the degree is n, then there will exist at max n minus 1 turning point. But exact number of turning points you can say only by looking at the graph. Okay. So now let's go to this example. So f of x is equals to x square into x minus 1. So I hope you guys are familiar with the graphs now. So suppose this is x is equals to 1. Now here x is equals to 1 is a root of multiplicity 1. If you don't understand those things, you can just go and check the video, that week 4 summary video. There we have discussed all those things in detail with examples too. Okay, so here x is equals to 1 is the root with multiplicity 1. So that means here polynomial will behave like a straight line. But first of all, figure out the end behavior. So here end behavior is easy. As x goes to infinity, f of x will also go to infinity. And I hope you guys are remember the reasons. And another root is 0. X is equals to 0 is another root with multiplicity 2, right? Because here we have x square. So that means here polynomial behave like this. So the polynomial start from this direction, will go into this direction, and then turn around and go into this direction. Okay. So this is the rough graph of this polynomial function. F of x is equals to x square into x minus 1. Okay, so here you can easily figure out what is the line. If you consider the line y is equals to half, then this line, this horizontal line, will intersect the graph more than once. Right? You can consider this line. Here we have
Ma'am,
3 intersection points.
ma'am, it means if the odd polynomial has only one roots, then it will be 1 to 1.
Yeah, you can say that. If it has only one real root, then it can be a 1 function. But if you add more than one root, then obviously it has to turn from some around, and you will get such a loop type of structure, and then you can find out a horizontal. So in this case, this is not a 1 function. Okay, is that clear so far? Fine. Now let's. So these are the 3 ways by which you can judge that a function is 1 or not. I'll repeat. So what are the ways we have? So the first way is the definition, which says that for different input, you have to prove this thing, f of x1 not equals to f of x2. The second thing you have is if f of x1 is equals to f of x2, then you have to prove x1 is equals to x2. The third thing is we have horizontal line test. And the fourth thing is you can find the counter examples. Okay, so that is by finding such x1 not equals to x2, for which, so that means just find any counter example. Like in the example of x4, we have find 1 and -1 will do the job, right? So same thing, you can find such a x1 not equals to f of x2, which imply f of x1 is equals to f of x2. So that is such an one particular type of example. So like
I have one doubt.
yes.
So can we say that only odd polynomials with only one root are one functions?
Yeah, we
Is there
can say
anything
that
other than
because
anything other than that?
see, if we have an odd polynomial which has two roots, then obviously it
Yeah, that
has
I
to
understood.
come.
Yeah, no, that I understood. I'm saying now I'm encompassing the entire one functions are only odd polynomials with only one root. There's
No,
no
no,
other
no.
one
So
function. Can I say like that?
see, we have trigonometric functions too, right? Sine function, cos function, and now we will see exponential functions. So exponential functions are the good example of one functions. So there are functions which are not odd polynomials, still they can be
Got it.
one functions.
Got it.
Right?
Got it.
Okay. So yeah, exponential functions are a good example of one functions. They are not onto, but they are one. So for onto functions, we don't have those many ways to figure out. We can only figure out by graph or by definition. So I'm not going to onto function now, but we can understand them after some time. But these are the ways you can use for saying that a function is one or not. Okay. So I hope that's clear. Is that okay? Fine.
Yes, ma'am.
Okay. So,
Ma'am, I have a question. Like here we are covering one function in very much detail. Are
yeah.
we sometime in future going to cover onto functions as well?
Yeah, there are not those many ways. So in today's lecture only, I think we can cover onto function, but we'll see.
Okay, ma'am.
Okay, so I'll tell you the same. There are only 2 to 3 ways by which you can figure out a function is onto or not. So we can discuss that also. So after exponential and composition function, I'll go to onto function because it's better to understand now. Otherwise, once you go into limit continuity, you forget about these things. Okay. So now let's go to the next topic, which is our exponential function. Okay. So exponential function means, first of all, you figure out you will fix one value as your exponent. So for example, we are now going to see these kind of function, that 2 to the power x, 3 to the power x, 4 to the power x, 1.5 to the power x, and so on. So these kind of function, that is e to the power x type of function, are known to be exponential function. Okay, but there are several restriction over a. So one restriction we are considering that a is greater than 0. Right? Why we are considering? Because we want our exponential function to be defined for all real numbers. Right? So what we want that exponential function should be defined for all x belongs to real numbers. So that means I want to consider the domain of these function as the whole real numbers. But if you take a negative value, so suppose if you take the value of a to be -1, then we know that -1 to the power half, which is root of -1, is not a real number, right? So in this case, I have to remove all the rational powers of -1, right? So 1 by 2, 3 by 2, and all those things. So it will complicate the domain of exponential function. So that's why if you are considering f of x to be a to the power x, then the first restriction we assume that a is not equal to 0. A is strictly greater than 0. And also we are not considering a is equals to 0 because you know that if a is equals to 0, then f of x, which is nothing but 0 to the power x, will become 0, a constant function, right? So there is nothing new in considering a is equals to 0. Okay. So again, if you consider
rational powers are allowed in exponential function.
Yeah, they are allowed in exponential function. So in 2 to the power x, you can figure out what is 2 to the power 1 by 2. It's a real quantity, right? Under the root of 2 is a real number. Although it's irrational, but it's a real number, right? But if
Okay,
you
ma'am. And ma'am, negative power?
Yeah, negative powers also you can do. So that means 2 to the power, 2 to the power minus 5 if I want to calculate. It's nothing but 1 by 2 to the power 5. It's again a rational number. That is, it's again a real numbers. So you can consider negative numbers. All real powers, all x belongs to real number you can take. Right? So that means we can say that domain is the whole real number set.
Why A can't be
Okay, ma'am.
0? Can you come again?
Yeah, you can take a to be equal to 0, but it's not giving us something new. It's again a constant function, 0 function, right? So that's why we
Okay.
are not taking a to be equal to 0. Okay. Similarly, we won't take a to be equal to 1, because if you take a is equals to 1, then f of x, which is 1 to the power x, will again become a 1, which is a constant function, right? So that means these values of a won't give us any new information. They are just giving back the constant functions only. So that's why we are just removing those values of a. Okay, so first thing is, this is the restriction we want to consider whenever we talk about exponential function a to the power x. Another thing is, we are not considering the value of a to be 0 because it's giving us the constant function 0 only. We are not taking the value of a to be 1 because again it's going to give us constant functions only. So that means what are the left values of for a is, so the left values of a is, a could be in between 0 to 1 and a could be greater than 1. Okay, so these are the values of a you can take as the exponent of your exponential function. Okay, again I'll repeat, we are talking about the function f of x is equals to a to the power x. Okay, is that fine so far? Now see, here we can consider this exponential function's behavior in two ways. So first thing is, whenever you talk about exponential function, first you will fix the exponent. So that means first we will fix the value of a, and then we will talk about the function of a to the power x. Okay. So now in general, you can also see the behavior. So that means if the value of your exponent, that is the value of a, is in between 0 to 1, then this function's graph look like this type of thing. Okay, so that means it trying to reach the x-axis, but it won't. It will never reach x-axis. It just the values as x goes to infinity, the values of e to the power x will become very smaller and smaller and smaller. We can take the example. So suppose I'll fix the value of a to be equal to 1 by 2. Right, 1 by 2 is between 0 to 1. And now if you consider the function f of x is equals to 1 by 2 to the power x, which is the same thing as 1 by 2 to the power x, right? So here you can observe that as x goes to infinity, we know that 2 to the power x also goes to infinity. So that means 1 by 2 to the power x will go to 0. Is that clear? So that means if you take the value of a between 0 to 1, the graph of function will look like this. Now here you are getting one point where the graph is intersecting y-axis. So what will be that point? So that means if you take the value of 0, we will get f of 0 to be equal to a to the power 0, and a to the power 0 is nothing but 1. So that means the y-intercept is nothing but 0, 1. Okay, so this is the graph of exponential function if the exponent, that is the value of a, is between 0 to 1. Now similarly, we can say...
Excuse me, ma'am.
Yes, ma'am.
Ma'am, I'm just not able to relate one thing. Here we have now got 0, 1 as a coordinate. But again and again, we are saying that we are not considering a to be, a should be equal to 1. I mean, we are not taking that case. So how the two things are?
See. So a is not any value in between x, right? So here input is x. First you are fixing a, and then you are talking about the function. So here none of the values relate to a.
Okay,
So a to the
initially we
power...
have to not take a as 0 or 1.
Correct. So initially we haven't fixed. First of all, whenever you discuss the exponential function, you will fix your exponent first. So that means as like this. First I have fixed a is equals to 1 by 2, and then I can talk about f of x is equals to 1 by 2 to the power x function. Okay, so here we are first we will fix a value of a, and then this is the graph of function f of x is equals to a to the power x. So here you are varying the value of x's, not a. Okay, so here we are taking we are considering different values of x, not a. So here x is equals to 1, so that is this point will be 1 comma a, right? If you take x is equals to 2, this point will be 1 comma a square, and so, right? So first of all we are fixing exponent, and then we are talking about the function. Is that clear?
Yes, ma'am.
So Yeah. So similarly, we can figure out the graph of the exponential function when a is strictly greater than 1. So here you can take the example of a to be equal to 2. So you can consider the function f of x is equals to 2 to the power x. So the graph of this function will look like something this type of thing. Also, it will intersect. So that means here, if you take the value of x to be 0, what will be the value of a to the power 0? So anything to the power 0 is equals to 1. So that's why we are getting y-intercept to be 0, 1. Okay, so this is the graph of exponential function when the value of exponent is strictly greater than 1. Okay, so by the graph only, you can easily see that the exponential function is nothing but a 1, 1 function, right? So by the horizontal line test, we can say f of x is equals to a to the power x for a strictly greater than 0 and a not equal to 1 is a 1, 1 function. This 1, 1 function also known as 1 to 1 function. So there are several ways, right? Several names actually. 1, 1 function is same as 1 to 1 function, and another name is this injective function. So injective function means 1, 1 function. So injective functions are same as 1, 1 functions. Okay. So by
Why did you
horizontal
add
line
that
test,
clause for a greater than 0 and a is equal to 1, is it?
sorry, what?
Why did you add that clause by that for a is
Yeah,
greater than 0 and a equal to 1?
because for these value only you will get 1, 1 function. Ultimately, if you take because see here I am considering the domain of this function to be the whole real
That I
number.
understood. Like otherwise
Uh,
it will go into complex. But why a is
correct.
equal to 1? You can say a greater than
Because
0. No?
no, see, if you take a is equals to 1, then this function f of x is equals to 1 to the power x, which is a 1, a constant function, right? And it's not a 1, 1 function, right? Because for every value of x, you are getting 1
Then it
only.
should be a not equal to 1, no?
Sorry, yeah, it's not equal to. In my mind, it's not equal to, but I have wrote equal. Yeah. Okay. So that's why we have to remove 1. Because if you take 1, it's not a 1, 1 function. Yeah. So by horizontal line test, we can say that exponential functions are 1, 1 function. Now we can figure out some of other properties of exponential function. So I'll take case by case. So suppose we have first case is here when the value of exponent is between 0 to 1. Okay. So then the graph is a decreasing graph, right? You guys are familiar with increasing, decreasing function, right? So in this case, first thing it's a decreasing function. You guys are familiar with increasing, decreasing function, right?
Ma'am, can you tell us in brief?
Yeah, so so what is increasing function means? If you take x1 less than or equal to x2, the output should follow the same inequality. So that means then f of x1 should be less than or equal to f of x2. So that means it should increase as x increases. And the decreasing function means it should decrease as the x increases. Okay, so there is a little difference that says that if x1 is less than or equal to x2, then you should be able to figure out f of x1 is greater than or equal to f of x2. So here what is happening in the first case, in the increasing case, the uh, the output is also increasing as x increases. But in the second case, the output is decreasing as x increases. So that's why it's known to be a decreasing function. Okay, so the first is increasing function, second is decreasing function. Here by the graph you can see here, if I take this value of x1 and if I take this value of x2, then by the number line you can easily figure out that x1 is less than or equal to x2, correct? Because in the number line this is 0, so x1 is negative, x2 is positive, so x1 is less than or equal to x2. And again, this should happen for all x1, x2 belongs to domain. Okay, so this thing is kind of figured out. Now here, if you consider this point, then the coordinates of this point will become x1 comma f of x1, right? So that means this value is your f of x1. And if you consider the coordinate of this point b, that is x2 comma f of x2, so that means this value is your f of x2, right? So by the graph you can see that x1 is less than equal to x2, and it is also implying f of x2 is less than equal to f of x1, right? So here x2 is little lower than f of x1, so that means it's a decreasing function. So that is exponential functions are decreasing function.
Ma'am, in this the definition you have used the less than and I mean you have used the equality also.
There are strictly increasing, strictly decreasing functions. So if they use the word strict, then you have to remove the equality.
Okay.
Okay.
Ma'am, I have a question.
Yes, Palak. Palak.
मैम वो वीक 5 का जो कंटेंट डल गया है और अभी जुलाई में जो पेपर होने वाला है तो मैं उसमें पढ़ रही थी वीक 4 पूरे पढ़ लिए है मैंने तो 5 भी करना पड़ेगा कि रिवीजन भी करना है ना नहीं तो उसका वो
नहीं
पूछना था
वीक 5 नहीं करना है, वीक 5 छोड़ सकते हो बिकॉज वीक 5 का डेडलाइन भी 18th of July है, ग्रेडेड असाइनमेंट डेडलाइन इफ आई एम नॉट
तो
रॉन्ग।
वो नहीं करेंगे तो कोई प्रॉब्लम तो नहीं होगी ना क्योंकि
नहीं
रिवीजन
नहीं
वगैरह भी करना है इसलिए
नहीं कोई प्रॉब्लम नहीं, कोई प्रॉब्लम नहीं।
Ma'am,
You guys can
graded
skip
assignment
week.
of week 5,
Ma'am,
it's
deadline of week
8th of
5 is
July, ma'am.
हाँ 18th
yes,
of July,
ma'am.
18th ना?
8th of
Ma'am,
no,
it's
ma'am,
9.
शायद
Oh,
perhaps
No,
18th
ma'am
of
ma'am.
9
July.
July. Ma'am 9 July.
Sorry. हाँ
Ma'am, it's
Yes, ma'am.
9th of
9th
July.
July.
Yes,
मैम
ma'am,
उसे
9
करना
July.
है नहीं
हाँ करना पड़ेगा, ग्रेडेड असाइनमेंट सबमिट करने लायक तो करना पड़ेगा।
तो वीक 5 भी करना पड़ेगा
हाँ एग्जाम के लिए छोड़ सकते हो बट ग्रेडेड असाइनमेंट सबमिट करने लायक तो पढ़ना पड़ेगा।
मैम
अच्छा
एग्जाम में तो 4 तक ही आएगा ना, वीक 4 तक ही आएगा।
हाँ वो week 4 तक ही आएगा but see if you want to continue this course in this term only then you have to you have to submit the graded assignment of week 5, तो उसके लिए करना पड़ेगा। बट अगर ये कोर्स तुमको नेक्स्ट टर्म में रिपीट करना है या नेक्स्ट टर्म में कंप्लीट करना है तो फिर नहीं भी करोगे तो चलेगा। Okay, so yeah,
Ma'am,
let's get
can we say that if a is between 0 and 1 then it's a decreasing function, and if
yeah
greater than 1 then it's increasing function?
it's an increasing function, correct. So here we have that it's a decreasing function if the value of a is between 0 to 1. Okay, now you guys can figure out the limits too. So that means if x not, it's better to not use the word limits. So here if I ask you if x goes to infinity, then where does f of x goes? Then a to the power x goes to, by the graph can you see?
Ma'am, 0 in this
0,
case.
right? Because if x goes to infinity, this values of a to the power x are becoming smaller and smaller and smaller, but it cannot be equal to 0 at all because we know that a to the power is equal to 0 means a equal to 0. So this thing that means as x goes to infinity, a to the power x goes to 0. And the second thing is if x goes to minus infinity, then a to the power x goes to infinity, right? So here you can see in the graph that as x approaches towards minus infinity direction, this graph is growing to upward, right? So that is it goes to infinity. So that's why this thing is happening. Okay. Now, yeah, that's all for yeah, these are the things we want to figure out. Now let's consider the second case when a is greater than 1. So when a is greater than 1, this is the graph of exponential function, right? So it's an increasing function, right? By the graph only you can see it's an increasing function, and as x goes to infinity, a to the power x will also go to infinity in this case, right? So here you can see as x goes to infinity in this direction, the graph is moving upward, so that means it's also going to infinity. But as x goes to minus infinity, this graph is approaching toward x-axis, so that means as x goes to minus infinity, this a to the power x goes to 0. Okay, so this is the end behavior of exponential function. And also you guys are familiar with basic properties, right? That a to the power r to the power s is equals to a to the power rs. A to the power r into a to the power s is equals to a to the power r plus s. These basic properties you can recall it, or you can also see in the lectures. Sir, I have covered these properties. So these are the very basic properties. Okay. Now, there is one more function which is known to be the natural exponential function. So what is a natural exponential function is, we'll fix a very interesting value of a. So that is our exponent's value a is e, which is also known as, it's e actually. So let's natural exponential function. So it's a function like f of x is equals to e to the power x. Okay. So where this e is actually the limit of a sequence. So you guys are familiar with sequences, right? So if you consider the sequence an to be equal to 1 plus 1 by n to the power n, then it turns out that this sequence converges, and the number where it converges is denoted by the symbol e. So E is actually the limit of this sequence. Limit n goes to infinity of an, or limit n goes to infinity of 1 plus 1 by n to the power n. Okay, so this number E is defined like this. Okay, so this is the definition, that we know that the sequence converges, but where it converges, so whatever the value is there with where it converges, and that value is denoted by E. Okay, so the reason behind this is we are using a symbol in place of number is because E is an irrational number. So that means the limit of this sequence cannot be write down in a finitely many decimal places, or you cannot write it down somewhere, anywhere. So that's why we are using a symbol to denote such a number like pi. Pi is again a symbol to denote a number which cannot be written, which cannot be finitely written down, right? So E is another type of number, and it appears in many physical experiments and all those things. So that's why we study the function natural exponential function e to the power x. Okay. So here the thing is,
Ma'am, a very basic question, ma'am. So whenever it's a to the power x, that's called an exponential function, and e to the power x, then it becomes a natural exponential function.
yeah, natural exponential function, but some people also called it as exponential functions only, because in general we won't talk about that much about e to the power x. We talk about e to the power x very frequently. So it's
Okay.
it depend person to person. It's okay if you call it exponential function too.
Okay.
Okay, but see, in the next week we are figuring out the logarithmic and the natural logarithmic function, right? So that's why we need this discrimination of natural exponential function and exponential function. But okay, fine. Now here the fact about E is the value of E lies between 2 and 3, right? So this is the fact that the value of E lies in between 2 and 3, and so that means that this E is greater than 1. Okay, so main thing is, so that is E is greater than 1. So that means the graph of this function will look like this thing. So this is the graph of f of x is equals to e to the power x, and the y-intercept is again 0, 1 only, because if you put the value x is equals to 0, you'll get 1 back. Okay. Now you can say that, okay, this is a 1, 1 function, right, by the graph only. It's a 1, 1 function. It's an increasing function, right? And as x goes to infinity, this e to the power x goes to infinity. And as x goes to minus infinity, e to the power x goes to 0. So these things you can just see by the graph. Okay, fine. Yes, Shivam, anything, any doubt? Fine. Okay, so this is our natural exponential function. And that's all about exponential functions actually. So what are the other things we can discuss? Yeah, there is one.
Ma'am, just a
Yes.
question. Ma'am, as now the maths syllabus is going towards exponential, and later on in math 2, maybe there's a calculus and limit and log and
Yeah.
everything. Ma'am, do you think if somebody who didn't had a maths in +2, they still can do the course?
They still can do, but they have to put some extra efforts. That means side by side they should have read the NCERTs and all those things to get more familiar with mathematics. Because see, these things are very handy for us to say, but if someone belongs from the bio background, they won't understand graphs that much, right? For them, it will take a time to digest. That's what
Yeah.
I want to say. Mhm.
Oh.
I think
Otherwise,
this is
it's
easy.
possible.
I'm also bio student. मैं फिजिक्स में ये ऐसा आता है ना तो ये आसान
हाँ हाँ
लगता है मैम ये अभी
हाँ,
तो आसान
करेक्ट.
है
हाँ, अभी तो चलेगा. जैसे लिमिट कंटिन्यूटी आएगी फिर थोड़ा सा दिक्कत हो जाता है, फिर तो मैथ्स पर्सन को भी दिक्कत होता है, तो बिना मैथ्स बैकग्राउंड वालों को क्या हो. Because the thing is, they have concentrated limit continuity differentiability in only 2 weeks, which is actually a less time to understand those things, but we'll figure it out.
मैम एक्चुअली मैथ
Ma'am, is there is
मैम
any
आगे क्या होने
predefined
वाला है
value of
स्टैटिक्स में कोडिंग में इसको क्या यूज होगा मैथ का
कोडिंग में तो थोड़ा डिफरेंट यूज होता है, इतना इन जनरल कैलकुलस का यूज उतना नहीं होता है, बट इट्स एसेंशियल टू लर्न, राइट?
Hey,
कैलकुलस
kind
उतना
request, can you
ज्यादा,
keep all this at the end because you're breaking the flow?
yeah, breaking the
Can
flow
you
actually.
can you please have these conversations at the end? Thank you.
Ma'am, is there is any predefined value for E?
Predefined, no. E is is a number where this sequence converges actually. So it's not a predefined value or something. So E is just a number which can be defined by limit of sequence, and it usually happen we define numbers by limit of sequences. So E is one of those numbers. Okay. So
Ma'am,
one
then
fact
how
I
we
want to
will
say.
solve e to the power x, such as, for example, e to the power 2. Then
So
how
e
we
to
will
the power
solve
2
it?
is the number e to the power 2 only. Yeah, we cannot write it down at all. You cannot say that okay, it's 1 point something something something. No, this is not possible. You cannot also write down pi. You can say that pi is almost equal to 22/7, but also you cannot write it down finitely. So that's why we have uses the symbols, right? E is a symbol, E is alphabet, because we cannot write those number in finitely many decimal places. It's not possible actually.
Okay, ma'am.
Okay. Uh, yeah, what I want to say is this fact that every increasing and decreasing function, so every increasing or decreasing functions are 1 functions. So that means if you find out any increasing function or any decreasing function, then that function is always become a 1 function. Okay. The reason behind that is their graph uh, will have no turns, right? So for example, if you are trying to figure out the graph of an increasing function, then it will look like something this only, because they cannot come down. Because if a graph, so suppose if a graph has such kind of loop, that means it is increasing in this way, but after this point it starts decreasing, so it's not entirely increasing function. So that's why we say any increasing or decreasing. Similarly, you can argue about decreasing function too. You can also prove this thing in detail, but I'm just leaving it. But you can, because we can imagine by the graph, right? Because the graph of increasing function cannot come down, so it's always behave pretty well. So you can say that every increasing decreasing functions are 1 function. Okay, is that fine, clear?
Yes, ma'am.
Okay, now we'll go to composition function. I think I have covered almost everything.
Ma'am, sir told something about the area under the curve from minus infinity to 1 being E. Can you explain that part?
Okay. Let's check. Area under the curve,
Yes, from
like
minus
this
infinity to
area. Is this area you are talking about?
yes, but it is like
Uh-huh.
a rather exponential function, like natural exponential function from minus infinity to 1. I think
Hmm.
it is E.
Yeah, so this you can see you can see it by integral actually. See, if you have this thing, I think you guys have learned in your 12th standard too. So if you have a function like this, and if this is the value x is equals to a, this is x is equals to b, and if this is the function f of x, then this area can be given by integration a to b f of x dx. This thing we also learn in our course too, but I'm just stating by using in the integral you can easily see. So this is the e to the power x function. So this area a will be integration 0 to 1 e to the power x dx. And the thing is, the integration of e to the power x is e to the power x itself. That's why it comes e to the power x 0 to 1. So that is e to the power 1 minus 0. So that is e minus 1. Sorry, e to the power 0. So that is e minus 1. So that's why the area under this curve is e minus 1. I don't remember how sir told it. But that's how, that's also you can see just by integrating e to the power x function. Is that okay, Meghna? Or to ask this out? I am not remember how sir told it, but yeah.
Ma'am, I have a doubt.
It's minus
Yes.
1, but I
Ma'am,
don't.
can't we take minus 2 to the
No,
power 3 as exponential function?
minus 2?
Minus 2 to the power 3.
No, you cannot take. See, exponential function means there should be a variation factor, right? So x should be there. So if you have minus 2 to the power 3, it's not a real number. So, sorry, it is a real number, but it's not a function. Okay.
It's a real number, then why it is not a exponential function?
See, function means the domain should be a set, right? Yeah, you can
So
say
2
that
b
it's a
power n
constant
is the
function, but it's
exponential
not an
function.
expression. Sorry,
2
what?
b power n is the exponential function.
2 to the power x is an exponential function. I think she asked about 2 to the power minus 3 or something like that. Yeah, 2 to the power minus x is also an exponential function because it's kind of obvious. If you take negative real number, it will become positive real number. Just
Weak
change the
radioactivity, etc. Bacterial growth radioactivity.
Yeah. Okay. So now let's go to the next topic, which is composition of function. Okay. So composition of function means if you have two functions and if you want to apply those two functions in a well-defined manner. So that means if you first apply f and then whatever output you will get, then you want to apply g. So this so you can write down this whole process as the composition of two functions. So what I want to say is, suppose you have a function f which works between the set a and b, and if you have a function g which started from set b to c. So then what you can say, you can say that the composition f g composition f is a function which operates on x like g of f of x. So that means first you will take input from a, you will get your output as f of x, and then on this f of x you will apply g and you will get g of f of x. So this is known to be a composition of two functions. Okay, so now the thing is, composition of two function is the important problem is to find out the domain of composition of two functions. Okay, so composition means simply, so I'll repeat again. So if f is a function from a to b, and if g is a function from b to c, then g composition f of x is a function defined like g of f of x. That means on x, first you will apply f, and then you will apply g on f of x. It's a composition of function. Similarly, you can talk about g composition f2 if the set is same. Okay. So now the problem here is to find out the domain of composition function. Domain of g composition f or f composition g. Okay. In general, we haven't taken a, b. We will take only real number set mostly. Okay. So now how can we figure out what will be the domain of g composition f or f composition g? Or I can say subset of real number, but okay. So now how we can find out the domain of f composition g and g composition f? So the first thing is
Can you scroll up a little bit? Can you scroll up a little bit? I didn't understand that subset part.
Yeah,
is
but
the-
see, domain changes now. So for example, if I want to take f of x is equals to 1 by x, then the domain will be real
don't go
number
in
minus
that
0.
detail. I'm asking why the codomain is real. It should
It's
also be
okay, it's
subset
fine.
of something, no?
No, it depends. See, codomain I can choose by my choice.
Okay, you have taken that
Right?
liberty. Fine.
So codomain does not affect that much. Okay, so yeah, what do we understand by domain first of all? So domain means the set of all values where the function is well defined, right? So domains means set of those x belongs to real number where the function f of x or where the value f of x is well defined. Again, I'll repeat what is the meaning of well defined means. It should not be a complex number and it should not be equal to plus or minus infinity, and it should not be a complex number. That's the meaning of well defined for us. So what do we want to find when we talk about find the domain of any function is we want to collect all those real numbers for which the output or whatever the value of function we'll get, that thing should not be equal to plus or minus infinity, and it should not be equal to complex number. So those values we want to collect, and whatever set we will get, that set will called as a domain of that function. Now here also we want to find out domain of f composition g and g composition f. Okay, so suppose first we'll start with the g composition. Okay, so how it defined, first understand that. So what is happening, if I take any value of x, first of all, this quantity f of x should be well defined. Right? So that means over x, the first restriction is that x should belongs to domain of f. Correct? Because if x does not belong to domain of f, then you cannot talk about f of x. So that means you cannot talk about g of f of x. So The meaning of G composition f of x means, first of all, f of x should be well defined, and then over this thing, the function G should be well defined. So that means G should be well defined on the value f of x. So we use these two restrictions to get some steps to find out the domain of G composition. Okay. So here you can
So
find
G
out the
should be well defined for range of f of x or domain of codomain of f of x. Which one will
range
you
of
say?
f of x actually.
Range of
Range,
f of x.
range. Yeah.
Okay.
Okay. So domain of G composition f of x. Okay. So first of all, what you will do? So here is steps. So step number 1 is, first of all, you will find domain of G and domain of f. Okay. So first of all, you will figure out what is the domain of G and what is the domain of f. And then what you will do, the second step. So in the second step, we have to remove some point from domain of f, because here you can see that first of all, f of x should be well defined. So that means x should belong to domain of f. So you can say that the domain of G composition x is kind of subset of domain of f. Because first thing is f of x should be well defined, and for being f of x should be well defined, x should belong to domain of f. Now in the second step, what you have to do, you have to remove some points from domain of f. What points we have to remove? So we have to remove those points for which f of x does not belong to domain of G, because then G of f of x is not a well-defined thing. So in the second step, what we will do, we will remove those x belongs to domain of f for which f of x is not a part of domain of G. Okay, and then the leftover, then whatever we'll get, that is our domain of G composition. Right? Okay, so these are the two steps. So whatever left you will get, these are the domain of decomposition. Yes, any doubt?
Ma'am, can you
Can I ask
repeat
a doubt?
one more time this?
Yeah, so I'll also take one example. So first thing what you will do, if you want to find out
Pehले
domain of
just give me example, then after then step.
yeah. So yeah, so let's take one example which is similar type of example done in the lecture. So here I'll recommend that don't go by the go by the expression. So that means I'll repeat that what I'm saying. So example says like this. So suppose f of x is equal to 1 by x minus 3 and g of x is equals to 1 by x. Okay. So here we want to find out find the domain of G composition f. Okay. So first step says find the domain of G and find domain of f. So what is domain of G? What is domain of G? If G of x is 1 by x.
All real numbers except 0.
Correct. And here domain will be the set of all real number except 3. Because you know that whenever we have rational functions, we have to remove those points where denominator becoming 0. So at 0, this denominator becomes 0. And at 3, this denominator becomes 0. That's why domain of f is real number minus 3. Domain of G is G is real number minus 0. Okay. Now the second step says remove those x belongs to real number minus 0, which is domain of f, for which f of x does not belong to domain of G. Okay. So domain of G is, I think I missed here, this is a real number minus 3. And here this is a real number minus 0. Okay. So what you have to do, you have to remove those values of x for which f of x is not there in real number minus 0. So what is the point which is not there in real number minus 0? So ultimately, you have to remove those points of x where f of x is becoming 0. Right? Because 0 is the only point which is not there in domain of G. So can we say that is there any point where 1 by x minus 3 is equals to 0? Okay, so in place of x by 3, let's take it x here. So that we can get a point to remove. Domain won't change, right? In place of x. Okay, so that means if you want f of x is equals to 0, that means x by x minus 3 is equals to 0. This will imply x is equals to 0. right? So what you have to do, you have to remove x is equals to 0. So this means remove x is equals to 0 from domain of f. Okay, so whatever the leftover is, that is our domain of G composition f. So that means domain of G composition f is domain of f minus the point 0. So what is domain of f? It's real number minus 3. And also we have to minus the point 0, that is real number minus 3 comma 0. Minus 3 comma 0. So that's how you can compute. The one thing I want to say is don't go by the expression. So here, if you go by the expression, so by the expression, if you find out G composition f of x, that is actually G of x by x minus 3, right? Because f of x is x by x minus 3. Let me know if I moved too fast. Okay. So this is nothing but 1 by x minus 3, which is equal to x minus 3 by x. So now if you consider the domain of this function, then the domain of this function is only real number minus 0. You are considering the point 3 too. But the thing is, the point 3 at x is equals to 3, this thing is not defined. So that's why the domain of G composition f is real number minus 0 and 3, not only minus 0. That's why don't go by expression, go by steps. Okay,
Hey,
is
you
that
lost
correct?
me completely.
Ma'am,
Like,
can you please
you
repeat
lost me
this from
totally.
steps second?
I don't understand
Yeah.
anything, whatever you're talking right now.
Okay, see. First of all, we want to compute domain of G composition f, correct? What I want to say is, if you just go by the expression means if you first compute the expression of G composition f and then try to find out domain, then you may miss some points. That's the point I want to say first.
Yeah,
Okay.
that I got it.
Yeah, because here, if you go by expression, you will get the function x minus 3 by x, whose domain is real number minus 0. But it's not equal the domain of G composition. Why is that? Because if you consider by steps, so what does step says? First of all, find the domain of G, domain of f. I think this much is clear to everyone. Then what you need to do is, you need to remove those points from domain of f for which the value f of x is not there in domain of G. Okay, but what are the values are not there in domain of G? Domain of G is real number minus 0. So that means 0 is the only point which is not there in domain of G. So that means you have to remove those x belongs to real number for which f of x becoming 0, because this is not there in domain of G, because G of 0 is not well defined. Right? So if f of x becomes 0, you cannot apply G function on that. So that's why we have to find out that value of x for which f of x is becoming 0. And now I change the expression of f of x to be x upon x minus 3. So that means you want to find that value of x for which x upon x minus 3 is 0. But this is happen only when x is equals to 0.
This
So that
step I didn't
means
understand. X by x minus 3 equal to 0 means x tends to x equal to 0. How did you get that? If I take left to right, x is equal to x minus 3, I'll get.
0
But
multiplication, right?
okay. Got it.
X is equals to 0 into x minus 3. No?
Silly me, sorry.
Okay, so that means x is equals to 0.
Excuse me, ma'am.
Yes, sir.
Yeah, so in the domain of f of x, we should remove both 3 and 0.
Correct. So in the domain of G composition f, you have to remove both points 0 and 3. 0 because sorry, yeah, 0 because G is not well defined at f of 0. F of 0 is 0. That's why G is not well defined at 0. And 3 because f of x is not well defined at 3. So that's the chain. We are applying functions over the chain. So first thing is x is there. We are applying f to get f of x, and then we are applying g to get g of f of x. Right. So first of all, on this x f should be well defined, and on this f of x, this g should be well defined. Right. So here
Maybe
g
can
is
you
not well.
take another example?
Yeah, I'll take another example. I'll consider the root function now, but try to understand this one because this is the simplest one. Because here we just have only one point which we need to remove. Okay. Okay. Is this example
Ma'am,
clear?
if
A little
we,
bit clear?
ma'am, if we replace g of f with f of g, then the domain will change.
Change. Yeah, then the domain will change. Okay, so let's try to do that.
No,
Now
I have
we
one
have
more follow-up, one small follow-up.
ma'am.
See, you said initially we were speaking about g of f. You said g of f should be well defined for the range of f of x, correct?
Correct.
So in that sense,
But if range
it should be
involves some
defined
point
for
where
all. No, did you
yeah.
understand my question? Since you said
So but
range of f of x, then all ranges of f of x should have uh, the g of f,
no.
right?
No. See, but if we have such a function which is not entirely defined on, that's why we have to remove one point so that this g of f of x makes sense.
Okay.
Right?
Okay.
That's why we have to
What
remove.
is the final answer of this question?
Final answer will be the domain of f minus those points which you want to remove. Right? So domain of f minus 0, that is real number minus 3, 0. Okay,
So
ma'am.
basically, the range of f of x doesn't involve the domain 0 in its domain. So you're removing it in. Okay. Get that.
Okay. So because you have to understand that we are using a chain, so we are applying it by first we are applying f and then
Yeah,
we are
now it's a
applying
little more
c.
clear. Yeah. Thank you so much.
Okay. So yeah, now we'll try to find out the other domain. So one thing is you can also this fact that the domain of G composition F will always be a subset of domain of F, and the domain of F composition of G, F composition G, will be a subset of domain of G. Okay, because see, we are applying F. So for applying F, F of X should be well defined. That means X should comes from domain of F. And in the second thing, that is F composition G, first we are applying G. So that means G of X should make sense. So for that X should comes from G, the domain of G. So this is one
Now
fact
this
you can
rule
always remember.
clears much of my doubts. Yeah, thank you.
Now, see, f of x is x by x minus 3, and g of x is 1 by x. Okay, so here domains are, so this domain is real number minus 3, and this function's domain is real number minus 0. Okay, now we want to figure out the domain of f composition of G. Now this will be a subset of domain of G. So that means real number minus 0. But now we have to remove those x for which this g of x is not a part of domain of f. Because see, I want to define f of g of x, right? So for defining f of g of x should be a part of domain of f. So if you get some x for which g of x is not there in domain of f, then you cannot talk about f of g of x. So that's why we have to remove those x for which g of x is not there in domain of f. Okay, so what is not there in domain of f? So domain of f is whole real number minus 3. So here the only point which is not there in domain of f is 3. So we know that this f of 3 doesn't make sense. Right? So now what we will do, we will remove those x for which this g of x is becoming 3. We will remove those x. Right? And we will remove those x from domain of G only. Because if it lies, it is not there in domain of G, then obviously we cannot talk about G of x. So we have to remove those x which is in domain of G, but for which the value of G of x is becoming 3. And why we are removing that? Because we know that f of 3 doesn't make sense. Okay. So now here let's try to find out those values of x where G of x is becoming 3. We know that 1 by x is becoming 3. So that means x is becoming 1 by 3. Right? So that means if you take x is equals to 1 by 3, then g of x will become 3 and f of 3 is not defined. So that means you have to remove 1 by 3.2. So that means this will implies that the domain of f composition of G will become domain of G minus of the point 1 by 3. But what is domain of G? It's real number minus 0 minus of the point 1 by 3. So that means now we have to remove 2 points. From real number, we have to remove 0 and we have to remove 1 by 3. So this is the domain of F composition. Is that clear now? A little bit clear?
Yes, ma'am.
Yeah. Okay.
Ma'am, so then for f of g of x, the domain of the function is a subset of the domain of g of x, and the range is a subset of the range of f of x. Is this correct?
Correct, correct. Yes, that's correct.
And then it reverts, then like it inverses for g of f of x, then vice versa.
Right. Okay, because you have to remove this, you have to remember this thing that first we are taking x, applying f on that, and then taking f of x, and then applying g on that.
Huh.
Okay. Okay, so now there are several examples you guys can do those examples. I can also take one more example. Let's see. And also, don't go by expression. In expression, you might miss some of the points. You will reach a little bit closer to the domain, but you may miss some of the points. Okay, so let me take one example. So suppose f of x is equals to the under the root of x function, and g of x is equals to the 1 by x square function. I don't know if we get the same domain or not. I'm just taking example by one. Okay, so here the domain of this function is domain of f is positive real numbers, right? So I'll write it there, r greater than equal to 0. Okay, I hope this notation is okay. Or let me write down that x greater than equal to 0. Okay, so this is your domain of f, and domain of g is as usual real number minus c. Okay, now let's try to figure out what is the domain of G composition f. Okay, so first thing is it's a subset of domain of f. So that means we have to consider x greater than 0 points only. Now, what are the points we are left are not there in domain of f is negative numbers. Okay, so now you have to remove those x such that g of x is less than 0, right? Because if g of x, sorry, f of x is less than 0. Because if f of x is less than 0, then it's become a, what I'm doing? Yeah, I'm so confused now. A domain of f is x greater than equal to 0. Now we have to remove those x for which f of x is not there in g of domain of g. Yeah, so we have to remove those x belongs to domain of f for which f of x is not there in domain of g, because we want to talk about g of f of x. Yeah, so domain of g is real number minus 0. So that means you have to remove all those x belongs to domain of f for which f of x is becoming 0. Right? So that means
So
under
it will
the
be
root,
x is greater than 0.
root x becoming 0 means x is equals to 0. So you just have to remove the equal to point, right? Greater than 0. So this will implies domain of G composition f is x strictly greater than 0. Okay. Now you'll do a little bit of practice by your own, then you can figure out how to compute. Also, we can take some of the examples too on domain of composition function.
Hello, ma'am. In this example, I only need to remove x is equal to 0. Am I right?
Correct. Yeah, right. Only 1 point, x is equals to 0. Okay, I'll cover this topic in the next sessions only, but we'll see. You guys try to do some of the examples by your own. Then it will be a little bit settled to you that what we are doing actually. Okay. Now there are 57 students. Yes, sir.
फोर्थ वीक मैं फोर्थ वीक तक का जो कंटेंट है वो 13 था, वो क्वालिफायर एग्जाम में आएगा या फिर उससे ज्यादा आएगा?
नहीं, week 4 तक ही आएगा सर, week 4 तक. Okay, so these are
There is
the
inverse function, right? Like you missed out inverse function.
so for inverse function I have to talk. So I was planning to take inverse function in the week 6 summary, but we can take it now. We have time. So that's all about exponential function. The important part of exponential function is finding the domain only. All other things are very standard.
Composition function.
Sorry, yeah, compositions function. Now you can think about some questions like what happen if f is 1 1, then can you say that f composition G is 1 1 or not, or G is 1 1, then can you say if composition G is 1 1 or not. So those things are left to you guys, or in activity also you can find such type of question. So try to figure out that, otherwise we can discuss it in the doubt session. So yeah, so now let's go to onto functions. Because the inverse function is nothing but the combination of 1 1 and onto function. So if a function is both 1 1 and onto, it's known to be an inverse function. That function will possess an inverse. Okay. So what is onto functions? Onto functions are also known as surjective functions. Okay, surjective, that means onto. Injective, that means 1 1. So if you have a function f from a to b, where b is your codomain, then this function is said to be an onto function if the range of f is same as the codomain of f. Range of f is same as the codomain, then f is onto. Okay, so what is means range of f equals to codomain means, first of all, what is the meaning of range of a function f? So range of f means you have to select all those values from the codomain which possess the inverse image. Inverse image means there should exist an x in your domain such that f of x is there in codomain. So that means you have to collect all those b belongs to b such that there is an x, there is an a in a, such a way that f of a is equals to b. So that means ultimately you have to collect all f of a's for a belongs to a. Okay. So in both ways you can understand the range. So range means ultimately you have to collect all those elements from your codomain which possess a pre-image. Right? So pre-image means this A. This is a pre-image. So you have to collect all those B belongs to B which has a pre-image in A such that f of A is equals to B, or else you can just simply collect f of A is where A belongs to A. Both things are same. So this set is known to be the range of a function. And if the range of function is same as the codomain, that then function is known to be an onto function. Okay, so this definition is one way to figure out that a function is onto or not. There are other ways too, but those ways are not the general ones. So general ones mean it need not always work. But one thing I'll suggest that you can see by end behavior too. So this is one way, just by applying the definition that okay, can we find an x for which we get an y. Okay, so we can take an example for this. So example is let's think of one function.
After seeing this definition, there is a question. If codomain is not given, then we cannot find onto. Then we cannot know that a function is onto or not.
See, if the codomain is not given, so that means you have to consider the whole real number set as your codomain. So in some cases, if codomain is not mentioned explicitly, consider the whole real number set as your codomain and then work out. Okay. If it's not given, then general thing is real number is there. The set of real numbers. Okay, fine.
Yes, ma'am. Okay.
I was thinking about an example. So let's see if this function is onto or not. So if I give you the straight line, then obviously that's an onto function. But I was thinking a little bit more. So suppose a function f of x given in like this 3x plus 2 upon x minus 1. Okay. And I also don't know this function is onto or not, but let's try to see by the definition, can we find a pre-image where we got our back. Okay. So if you want to think that this function is not is onto or not, so that means what? So what we want to find? So for y belongs to real number, I want to find and x belongs to real number such that if I append this x in my f, I'll get y back. So that means f of x is equals to y I should get. Okay. So that's the x I want to find. Okay. So suppose I'll take any arbitrary y because this should be true for any y, right? So what you need to do, I want to find an x for which y is equals to 3x plus 2 by x minus 1. Okay. Now I'll just solve it for x is equals to y terms. So this is written in y is equals to x terms. I want to write it down in x is equals to y terms. So for that, what I'll do, I'll just cross multiply by x minus 1. 3x plus 2 we have multiplied by y. This is xy minus y is equals to 3x plus 2. And then I'll take all the x term over the left hand side and all the other terms over the right hand side. So that is this xy minus of 3x is equals to y plus 2. So that means x I can take common, y minus 1 is equals to y plus 2. And that means x is equals to y plus 2 by y minus 1. Okay. So here I get that if I take x is equals to y plus 2 by y minus 1, I can get f of x is equals to y back.
It's not y,
Right.
y minus 1, it's y minus 3.
Y minus 3. Sorry, yeah. Y minus 3. Thank you. So that means if I take y to be any real number, and for that y, this will be my x. Okay. Now here the thing is, this x can work only if y is not equal to 3. Right. So that means if you take y is equals to 3, then there is no x for this y. No x, such that f of x could be y. Right. So that means for this y is equals to 3, I cannot find an x for which f of x is equals to y. So that means for this y is equals to 3, we don't have a pre-image. Right. So for this, don't have a pre-image. So here the codomain is not given to us, so we can consider the whole real number as our codomain. So that means from the codomain, the point y is equals to 3 does not have a pre-image. So we can say that it's not a onto function. Okay, so this is one way you can figure out that.
If the
Yeah.
domain was real numbers minus 3, then this is an onto function, right?
The real number minus 3 minus.
If the domain
No.
was initially the domain was
Codomain.
no, you have taken initially the x element of real, no?
Yeah.
Scroll up.
Hmm.
No, I'm asking you scroll down, sorry. Scroll down.
Yeah,
Initially,
sorry,
on the very first step, you said, I want to find an x element of real, no? So
Hmm.
if the domain itself, x domain was a real number minus 3, then this is an onto function, correct?
No, see, if you remove real number minus 3, then we are not getting any x for which f of x becomes 3. Right? There is no necessary to remove some points from the domain. If you want to make this as an onto function, we want codomain to be equal to domain, right? So we have to remove 3 from codomain.
Codomain, okay.
Codomain. Because
Yeah,
for y is equals to 3, we are getting problem, not for x is equals to 3.
yeah, understood.
No?
Okay, thank you.
Okay. Also, see, handling onto by this pen and paper is actually very difficult. There is no specific way to claim that a function is onto or not. Like this will work only for such type of function. If you have this type of function or little bit solvable function for which you can, reverse the relation between x and y. That means I can explicitly find what is my x in terms of y. So if this thing you can do for those functions, then okay, you can. What if y is equals to minus 2? Yeah, if y is equals to minus 2, your x will be 0, right? So that means if you just substitute x is equals to 0 here, you will get minus 2. So for y is equals to minus 2, we have pre-image. Someone asked in the chat, that's why I asked. So this type of thing will work only if you can reverse the relation between x and y, but it generally need not to be true. So for that, in general cases, you can use the help of limits. That's also not that obvious, but yeah, you can find out the limit as x goes to infinity and x goes to minus infinity or something like that. Okay, so by the graph also you can say, by the graph you can just the onto function. Okay, how can we judge by the graph? So suppose you have a function f from set of real number to set of real number. So that means the set of real number is your codomain. Okay, in that case, if your graph if your graph look like this, right? So here what is happening, as x goes to infinity, this is also going to infinity, and as x goes to minus infinity, this also goes to minus infinity, right? So suppose that's going to minus infinity. So then here every real number has a pre-image, because you can just draw a line, and for that y value you can find out the x values. So if such kind of scenario happen, then those kind of function will become onto function or surjective function. Okay, so
Ma'am, that means there has to be no break basically. Like it has to be
uh, not about break. I mean, it has to cover the entire y-axis, right? So that means no matter what value of y you'll choose, if you draw a line, it should intersect the graph at least once.
So, ma'am, like trigonometric functions, sine theta and cos theta, they are not onto function.
They are not onto function if you consider codomain to be real number, right? That's why I'm saying there is a restriction over codomain. So if you consider the codomain to be whole real number, then the graph of sine will look like this, right? So obviously, if you consider y is equals to 2, then there is no pre-image, because this line does not intersect the graph. So they are not the onto function. Onto function means for every value of y, you should be able to figure out an x on which if you apply the function, you will get y back.
Can I say
ma'am,
that
in the
it should
case of
pass vertical like
One
this?
by one, one by one.
Ma'am, can you repeat the last?
Yeah, the last thing I was saying that the main concept of onto means for any y in codomain, you should be able to figure out what is your x in the domain, which will give me this particular y back. Okay, so here if you take y is equals to 2, then this line is not intersecting the graph. That means there is no x for which f of x can become 2. Right? So this thing you have to figure out.
So, ma'am, here if we fix the y limit -1 to 1, then
Then
this
it
is
will
a
become
onto
onto.
function.
Yeah, this
Oh,
is an onto function.
Can
Yes, Sujit.
I say that if it satisfies a vertical line test, it is onto?
Vertical line test. See, this is not a vertical line, but you can say similar to vertical line test. Similar to vertical line test, because vertical line test used for function, right? But the concept is similar, that if there exists the same thing, that every vertical line should intersect the graph at exactly once.
Correct.
Yeah, so here also okay, so I can make a remark of that. Okay, so if for all values of y from codomain, okay, or as so for all values of y from the codomain, if we draw a vertical line, then that line should cut or intersect the graph at least once. For becoming an onto function. Okay, at least one, then we can say that that is an onto function. Onto or surjective, same words. Okay, so that means if you have codomain, and in that range of codomain, if you draw several horizontal lines, and if every horizontal line is intersecting your graph at least once, so there should not exist any horizontal line which is not intersecting the graph. So if every horizontal line intersecting the graph at least once, in that case you can say that that function is a onto function. Because what is happening, if every horizontal line is intersecting in the graph, that means for every value of y, you can figure out what is the value of x you will get, for which you'll get y back, right? So that means there exists a pre-image for every y. Is that clear? So I'll take one example too. So suppose
yes, ma'am, it is clear.
so suppose I'll take very basic example. So like this. Okay, so suppose this is your graph. Then here you can see, and if I say that the codomain is whole real number, then because of the end behavior of this graph, you can see that it's going to minus infinity from this direction, it's going to plus infinity from this direction. So no matter what value of y you will choose, if you draw a horizontal line, it obviously intersect the graph at least once. So that means for this y, here is your x. Right? So this x naught will give you y naught. Okay, so that's the horizontal line test. Now let's try to plot this function to see if what is happening over here. I also don't know how the graph will look, but let's try.
Ma'am, in what about the case where I am giving same value of y at different value of x?
Then that function is not 1-1 function. It can be onto, but not 1-1.
Okay, thank you, ma'am.
Okay, so let me share my screen. Okay, so see, this is the graph of the function y is equals to x plus 2 upon x minus 1, which we just did for onto, right? So see, this is the graph. So here, if you draw the line y is equals to 3, then this line is not at all intersecting the graph at any point. It seems like it is getting more closer and closer, but as I zoom in, the distance is much clearer, right? So that means this for this value of y, I'm not getting any pre-image. So that's why you can say that it's not an onto function. Okay, so such type of things can happen. So this is your horizontal line, which is giving us which is not intersecting the graph at any point, right? Is that clear now? How you can see the onto functions? See, onto
Ma'am,
functions are a big deal. So yes, Meghna.
Ma'am, one more question. Like we have this function 3x plus 2 upon x minus 1. Ma'am,
Mhm.
here we cannot give the value x equal to 1 to the function. Otherwise, it's a 0 in
Yeah,
the
it will. Yeah, domain is obviously real number minus 1. So you cannot give one value.
Oh, okay.
Yeah, but the thing is, we cannot get y is equals to 3 by substituting any value of x in this function. Okay. I hope
Ma'am,
that's clear.
we are not worried about x. We are only worried
Yeah.
about y.
Yeah, in onto, we are just worried about the range and codomain relation. We don't bother about domain if we are considering the onto. Okay.
Okay, in that
Yeah.
case, the definition which you gave, no, then remark, you wrote remark and gave a definition, right?
Hmm.
There, it should be horizontal line, no, not vertical line.
Hey, correct, horizontal line.
Oh,
Yeah, in my mind, I was drawing horizontal line, but stating
yeah,
vertical.
get that.
Okay. And what are inverse function? Inverse function are those functions which is both 1-1 and onto. Inverse, or also known as bijective function. Right. So those functions which are both 1-1 and onto. And known to be bijective function. And for these function, you can explicitly find out the inverse function. So that means if f is bijective, then there is a function known to be inverse of f inverse, such that if you find the composition of these two functions, so suppose f is a function from a to b, then the inverse will be a function from b to a, such that if you find the composition f inverse or f inverse composition f, both will be equal to the identity function x. That is f composition f inverse of x is same as f inverse composition f of x is same as x. So if you have a bijective function, then you can find the f inverse, and if you can find the f inverse, it automatically become bijective. So it's an if and only if situation. Okay, let's not do a bijective or inverse one. Fine. So here, this function is not a bijective function. The usual example of bijective functions are straight lines. All straight lines are bijective functions because you can easily see they are both 1, 1 and onto. So straight lines. You can also consider f of x is equals to x cube function. This is both 1 and onto from real number to real number. Okay, now can you guys tell me f of x is equals to 2 to the power x? Is this an onto function? If I consider codomain to be whole real number? What do you think? Is this onto?
For real number, ma'am, it is not onto. For whole numbers, I think it is onto.
Yeah, for real number, it's not onto. Yes, maybe. Okay, ma'am,
And
I was
for
doing the other.
natural numbers, it is not natural, but 0 to plus infinity.
Yeah.
It is on.
So see, now obviously 2 to the power x is not onto. If I consider the codomain to be whole real number, in general also, if you take the function f of x is equals to a to the power x, this is also not onto. If I consider the whole real number as our codomain, but if you restrict your codomain from 0 to infinity, then it will become both 1, 1 and onto, and that will lead us to define the definition of logarithmic function. So that I can cover in the week 6 summary session. Okay.
Ma'am, but from the graph we can place like all the horizontal lines, and we are always getting. I mean, it's always cutting this graph e to the power x.
Yeah, but if you consider y is equals to -1 horizontal line, then it won't, right?
Oh, okay, yes.
Okay. Now, similar
So it
one
should
last
be
question of the class.
y
and we
is
can-
less than y should be greater than 0, or y should be greater than or equal to 0 here.
strictly greater than 0, because for
Strictly
0
greater than
also you cannot
It's
find x.
undefined. Okay.
Undefined. Right. One last question I want to ask. So, if I give you the function f of x, what function we have started with, that is x to the power 4 plus 2x square plus 1 function. So, can you say is this onto?
No, this won't be onto.
And
No,
this
right?
again, for real number, this is not onto.
Right. Not onto. No. But because here it's kind of obvious because it will always give you the positive number because squares are there, power 4 are there. So, okay, since f of x is always greater than or equal to 0, no matter what x you take. Okay, that's why it's not an onto function. In general, can you say every even polynomial is not onto? Is this statement is true or false?
Yes.
Ma'am, it will be true.
Everything below the x component of axis of symmetry will won't have an free image.
Correct. So the statement is actually true. Because again, you can consider the end behavior too, you can consider the nature of polynomial too, that it will be symmetric. So just by end behavior also you can see. Okay. So that's all for today. So you can just go and revise these topics. These are very basic and important topics. And we
Ma'am,
can
should I
discuss the other. Yes, Devansh, what?
Ma'am, should I continue watch week 6 and upcoming lectures, or we should to prepare for qualifier exam only syllabus of week 4? What
Yeah,
is
the qualifier exam contains only syllabus up to week 4. But if you are done with that and if you have time, then you should continue. But I'll suggest at least do week 5. You have to although you have to submit week 5 graded assignment, right?
Ma'am, we have to submit week 5 graded assignment as well.
Yeah, you have to submit week 5 graded assignment if you want to continue the course in this term. As yes, you guys can ask doubts.
Ma'am, it is my first live class. So, if I want to prepare with the same classes which I have done before, because I'm getting my doubts clear like these classes. So, where would I get all the classes which I have done before?
On YouTube, you can find. There is a playlist on YouTube. Someone already shared the link in the chat box, so you can just go and check there. All the live sessions are there.
Okay, ma'am. Thank you.
Yes, it's
Ma'am, just a
Yeah,
request.
but TA sessions, the
Just
access
one
was
minute.
not given, ma'am.
Yeah, I have again told sir to give you the access because I don't have access to that file, so he only can give you. So I'll again remind him to give
The
the access.
activity question
Hello?
answers.
Ma'am?
There is
One by one, just one by one. Yes, HP, you can speak now.
Yes, ma'am.
Yeah, you was asking some doubt,
Yeah,
right?
I was asking, will there be some sort of remedial classes? Like, I'm having some difficulty in math, so will there be remedial classes?
Yeah,
Like,
there will be revision sessions on 8th of July.
okay, so will it
We
be like
have
a whole week, like all 4 weeks for a very particular subject?
Yeah, all 4 week for particular subject. So I'll divide the class in the 2 halves. So in the first half, we can just go through by the important topics and do some couple of the questions. And in the second half, you guys can ask your questions, whatever doubts are there, whatever leftover doubts are there. And if we need, we can also have one more revision session. But it's depend on the 8th July session. So if we can cover the whole thing at once, then we will. Otherwise, we can have one more session.
Ma'am, just a request. Ma'am, in the statistics, when we log into statistics, ma'am, they have made one tab and they are adding all the live recordings link there.
Oh, okay.
If something can be done for mathematics, it will
Yeah,
be
it can be done.
easy. Ma'am, because it's very difficult, and if we have to go through any, past classes, then so much time we have to spend in finding the link only, and then we don't end up into correct class.
Yeah, I'll ask support team to do this to our course too. Yeah, I'll ask them.
Okay, thank you.
For
Previous
TA
week,
recordings also, I have mentioned them couple of times, but I'll mention it tomorrow. Yes, Jay.
yeah,
for
previous
other subjects in
Kumari,
calendar, it is available, ma'am. For max, why don't you add like that, ma'am? It is very difficult or what?
On
TA
the calendar
like
only, na, that YouTube link.
no, ma'am. For TA sessions recording, I'm asking.
Okay,
For
okay.
all the
I'll mention them too.
recordings are there in the calendar itself. Only for
They
max.
should paste at least a link there, na. Yeah, I'll at least I'll inform TAs. At least they can put by themselves.
I sent mail in discussion forum also. I sent mail and the TA session some mail ID will be there, right? For that also I have sent mail, but no reply, ma'am.
No response.
Yeah.
Yeah, I'll mention this thing tomorrow in the morning.
Oh, okay. Thank you, ma'am. Because for revision it will be very useful because I have missed some of the sessions in between network issue was there. So it will be useful if it is there for revision for studying quiz one.
Yeah, okay. I'll
Thank
I'll ask them to put the link there.
Okay, thank you.
Ma'am,
Yes.
just one more request. Ma'am, in any of the doubt sessions, if we are asking questions from previous weeks, like sometime before I had problem in injective and subjective, etc. If I'm asking question from week 1, in some of the TA classes, they say that, oh, we are covering only this week, we'll discuss it later, but that later never happens. So,
Yeah,
ma'am,
this
please,
time happens.
if like whatever questions we are asking because we are finding it difficult or we want more info. So if something can be done about it.
What can I say is, see, you can ask them in revision sessions or like this time, right? When we are done with our theory part. Now you can ask such type of questions. For TAs, I don't know they will answer these theory questions or not, but in the instructor session you can ask those type of question at the end. So I can say that in instructions like that means this class 8 to 10 class, you can ask your whatever doubts you have at the end of all things. So
Yes,
like
okay, ma'am.
now I
Okay, ma'am.
can
Thank you,
spend
ma'am.
more half an hour to clear doubts, right?
Yeah,
Because
okay,
if you
thank you.
ask in between, other people might get bored and they will
Yes,
start complaining.
yeah, that's there. That's true.
Okay, yes, Rajiv, sorry.
Hello, ma'am.
Yes.
I have a doubt regarding I'm solving PYQ questions,
Hmm.
and there is a question saying there is a function px which is ax square plus bx plus c.
Yeah, can you share the screenshot of that question? PYQ question you
Okay,
are
okay.
talking about, right? In the chat, you can share. Because your voice is not clear, so that's fine.
In the calendar, previous weeks PDFs is not there anymore.
Yeah. Previous week's PDFs I haven't uploaded. I have uploaded only of theory sessions classes. I'll try to upload whatever I have.
Yeah, please do, because if you want to revise, then we need that PDF. That's why.
Yeah, I'll try to upload whatever things I have. I'll definitely upload this PDF because we have discussed the theory in detail.
Earlier it had week 4, but now
Week
I
4
think
I
it's
have
removed.
uploaded.
Now it's not there.
Now it's not there in the
Yeah,
calendar, no?
yeah, it is not there now.
Oh,
Earlier it was there.
yeah, I'll upload it back. Oh, the sessions also got removed, no? I think I.
Okay, please check that.
Hmm. I'll upload that. I'll upload this.
Okay.
Yeah, I have removed all the previous session. I think I'll change this. Okay, let's first complete this question. Just mail the support team, Shelly, because I cannot do anything about this. If they haven't responded you till the next class, then you can give me your email ID. I will contact them. Okay. So this is the question.
Yes, ma'am.
So q of x is equals to x square plus bx plus c, where a, b, c denotes the real number, e not equals to 0 of the following information. The maximum value attained by q of x is at x is equals to -1. Okay. So it says that max value is at x is equals to -1. Right. So first thing is they are asking about max value. So it is only possible if this parabola represents a downward parabola, because in the downward parabolas only where we can have a maximum value. So from the max value thing, we can say that okay, the value of a would be strictly greater than 0, and it is at x is equals to -1, and we know that max or minimum value of parabola occurs only at the vertex. So that means this point is the vertex. So that means this value -1 is actually minus b by a. So you can say that minus b by a is equals to -1. So that means b a is equals to b. So from this line, I get this information that a is strictly greater than 0 and a is equals to b. Now the second thing says that discriminant value of q of x is 8. Okay, so it says that b square minus 4ac
Ma'am,
is equals to 8. Yeah.
for downward parabola, it must be less than 0 now.
Sorry. Yeah. A must be less than 0. Thank you. I missed that. Yeah, so a must be less than 0 and a is equals to b. So now we can substitute over here. Uh, we have some relation over a and b. So it says that a square minus 4ac is equals to 8. Okay, so we get
Ma'am,
this relation. Yes.
vertex is equal to minus b by 2a.
Yes,
Yeah, ma'am.
thank you. So what it says that 2a
Ma'am,
is equals to b.
how do we get the relation of b square minus 4ac equals to 8?
It's given in the question. It's given that second point is given. This is given. There is a question in the chat. You can open the screenshot. So first point, it says that the maximum value attained by q of x is that x is equals to minus 1. So by max value, I figure out that the a should be less than 0 and this should be vertex. So that is minus b by 2a is equals to minus 1. That is b is equals to 2a. So this means that b square minus 4ac is equals to 8 means that 2a the whole square minus 4ac is equals to 8. So which means that 4a square minus 4ac is equals to 8. So we can say that a square minus ac is equals to 2. So this is another relation we get from the question. Now the third point says that slope at x is equals to 1 is 8. Right? So what is slope means? The slope of parabola is given by 2ax plus b. Right? So that means at 1 is 8 means that 2a into 1 plus b is equals to 8. So it says that simply 2a plus b is equals to 8. But what is b? B is only 2a. So it means that 2a plus 2a is equals to 8. So it means that a is equals to 2. Right? 4a is equals to 8. So a is equals to 2. So we get a is equals to 2. From a is equals to 2, if you append this a is equals to 2 over here, you can find the value of c2. Right? So a is equals to 2 means 2 square minus 2c is equals to 2. That means 4 minus 2c is equals to 2. So that means 2c is equals to 2. That means c is equals to 1. So you get the value of c to be 1. And you can also find the value of b because we have a relation in between a and b. So that means b is equals to 2a. That means b is equals to 4. So here we
I
get
have
a
a
is
little
equals to
question.
Ma'am, we considered first that a is negative. Then how we get a equals to 2?
That's also correct thing. So that means they
Yeah,
should
that's the problem.
yeah, that's
I
correct. So that
also
means
solved this question, but
yeah.
that is the problem. The equation I got at the end is 2x square plus 4x plus 1. But this is a downward parabola, so it should be the a equal to negative value. It should be less
Yeah,
than 0.
this
But
is I mean there is error in this question. They should have mentioned a minimum value here. In place of minimum
yeah,
value, they might have mentioned maximum value. It's just a mistake.
yes, that's the mistake. I got confused. So,
Hmm.
Ma'am, I
Yeah,
have a
that's the
little
mistake.
question regarding this question. How do we get the value of 2a equals to b?
2 is because it's given. See, this is the coordinate of x vertex, x coordinate of vertex. That is minus b by 2a is equals to minus 1. So that means b is equals to 2a, right? It's given in the question. 3 points are given in the question.
Okay, wait a second. But the equation of b upon a will always be there, na? Like if we want to figure out the slope or that thing, b upon a is always given for that, right?
No, it's a see q of x is given in this way. We have to figure out the value of a, b, c using the 3 points.
Can you just repeat the last sentence, please?
Yeah, so I was saying the q of x is given ax square plus bx plus 3, bx plus c, and the 3 points are given. So using these 3 points, we have to find out the value of a, b, and c. So there it's given that max value is at x is equals to minus 1. So this is the coefficient of vertex, x coordinate of vertex. So it's actually minus b by 2 is equals to minus 1. Got it? Or still confused?
Just one little question. What was the use of formula b upon a in the slope entire thing to find out the slope and that thing in the
See,
particular?
slope can be find out by this 2ax plus b. This is the slope at point x. Slope is not b by 2.
Ma'am,
That
then
means
why we have equated the slope with 8?
it's also given in the question. So you guys can see the question. Can I? So this is the question. See, here it's given slope, like slope of the function at x is equals to 1 is
Okay,
8
okay.
means that
Yes,
Yeah,
ma'am.
2a plus b is equals to 8. So here it's given, this is an error. There should be a minimum value, not max. Okay, so minimum value attained by q of x at x is equals to -1. So that is minus b by 2a is equals to -1. So that means b is equals to 2a, right? And here discriminant value is 8. So that means b square minus 4ac is equals to 8. So if you just apply this quantity over here, you will get a square minus ac is equals to 2. If just try to solve it, you will get the value of a to b 2, b to be 4, and c to be. Okay, then if there are no other doubts, we can wind up our session.
Okay, thank you so much, ma'am.
Yeah, thank you guys for joining. See you in the next class.
Thank
I'll
you, ma'am.
upload the notes again.
Okay, thank you, ma'am.
Thank you, ma'am. Bye, ma'am.